Hello and welcome to the Tech for Climate podcast. I'm Guillaume, your host, and each week I'm fortunate to share with you stories from climate tech founders, investors, and corporations sharing their unique insights into this fast-moving industry. Eventually, like me, you will learn, discover, and get inspired by those unique men and women who are contributing to the fight against climate change, and I hope it will help you to take a step in this formidable movement. So before we start, I just want to share a few words about us, as this podcast is just the tip of the iceberg of what we do at Startup Basecamp to support the climate tech movement. Our mission is to accelerate capital deployment towards climate tech founders, allowing them to focus on scaling their solutions. How do we do that? Every day, we help founders access to resources and connection and gain the visibility they need to expand their growth. We do this in a number of ways with a membership platform, a Slack group with a growing number of founders, investors, and experts from around the world. And recently, we went one step further with the matching services to connect founders with top climate tech investors. Keep in mind that we are able to do all of this thanks to the support of our listeners and our members. So please like and subscribe, share one episode with a friend, join a community, and if you haven't already done so, make a small donation to support our work. It really means the world to us. And now, enjoy the show! Hi everyone, for this newest episode of our Founder Series, we sat down with Ionathan Lazovski, CEO at Structure Pal, which provides engineers with the tools to reduce concrete volume in their design using a powerful novel AI. Ionathan has been involved in the construction industry for a long time and came to the realization that the house he would design as an architect was never the one that he could be constructed due to inefficiency in terms of cost and materials. He knew that tools existed to optimize construction methods, and driven by a desire to keep the planet inhabitable for his children, he founded Structure Pal. In this episode, we take a look at the problems with the construction industry and its inefficiencies and find out which materials are greener than others. In doing so, we learned about the gap in the market Structure Pal feels, how is it affected by regulation, and how Structure Pal and its team of engineers addressed it. In the second part of the show, we learned some top pitching tips from the winner of our pitch competition and Ionathan's secret sauce for building a successful business while also maintaining a work-life balance. Ionathan, welcome to the show. Hi, Ionathan. Welcome to the Tech for Climate podcast. I'm super happy to have you here with us again today, as you are the winner of the quarterly global pitch competition that we organize for climate tech startups. And you want the chance to join the podcast. On top of that, I think this is a great opportunity to hear your story, learn more about your exciting adventure to optimize the build structure for a carbon-free future with Structure Pal, which has been developing native design tools along with a powerful novel AI optimization engine. And we speak a lot about AI nowadays, so we'll love to learn more about that. So welcome to the show.
Thank you. And thank you for having me, Guillaume. It's a pleasure.
So before we start, that's the tradition on the show. Can you give us a 30-second introduction about Structure Pal?
Well, for sure. So the construction industry is, without a doubt, an industry that uses too much material, and to be more precise, more than it should, because we tend to overdesign everything. Structure Pal is here to eliminate, or at least reduce to the maximum that overdesign in terms of material, and we begin with concrete, which is the worst one.
So let's start from the top. In this show, we love to know more about like who is the man or the woman behind the company before diving into the career and the company and the industry. So can you tell us a bit more about like your story and background? I mean, what are you passionate about? What do you love to do besides building Structure Pal? What makes you feel inspired or like your best self? As I always ask, who is Ionathan?
Okay, so who's Jonathan? On a nutshell, let's go. So 12 plus years in this industry called construction tech, even before anyone called it construction tech. I come from an architectural background, bachelor, master degree, even a partial PhD that I didn't finish yet. I taught in the academy. I even, had a few exhibitions that I curated about this theme of how to optimize our industry, how to use AI for this cause, how to make our industry efficient and better. And the idea of making it more, say, sustainable just came along with the optimization notion. A few more words. Well, I'm a father of four, married, lives in Israel. And to be honest, from the moment my first child was born, I think that the sustainable and the climate issue became more prominent from the reason that is I don't want these guys to go to school in wearing spacesuits. I want them to enjoy the same life I had, same environment I had growing up, not refraining from the sun or the air for that matter, and having a winter, which is something we don't really have anymore in Israel because everything is warming up. So that's just a little bit about myself.
So before we dive a little bit more about like the company, I like to get a sense of like maybe you have like one or two pieces of experience before the launch of Structure Pal that in a way gave you edge to start the company. If you could share that with us.
So I think that working as a designer, an architect, one of the things that you can always see is that you envision great buildings, most of them sustainable, most of them are very good, not only in climate-wise, but actually good for the people who are gonna be residing in them, whether it's residentials or schools or municipal buildings, every of that kind. But eventually you see that you get to a point where it's not at the end the design, when you finish the design and the budget it's in and everything is compiled, it's not what you dreamed about. And that point pushed me to that point to say, okay, we need to do something about it and to understand why we're getting these mediocre buildings instead of the dream buildings that we could design and could build. And one of them drove me into this world of economics at the first stage. It means, well, it's too expensive to build. Well, it shouldn't be too expensive if we can optimize it and see how to keep the design, how to keep the quality, but reduce the cost, and that's possible. But there was nothing that could help with that. So in the beginning, I started working with generative and parametric tools. That was the avant-garde back then, 12, 13, 14 years ago, because you could actually tackle that thing about optimization in a very rough, I'll say, and I'll say it wasn't that mature at that time. So it helped a little bit, but I could notice that this is a base for something bigger that has to happen in the future. And that's where I turned more into AI and machine learning and tried to understand how to apply it into the industry. And that was the moment of eureka in terms of theory for me, and philosophy and theory, let's say. The fact that AI should be taking part of our industry, should be used even more than just a tool. And here we are today.
So before we dive into the company, what we like to do on the show, it's always kind of like take a zoom out and more like try to understand like the larger context that you are on. So let's try to get your overview on the so-called construction industry and its contribution to climate change today. I mean, to structure this, I like to start with maybe the general contribution on the material side, and then go deeper to understand the challenges of the allocation of those ones by the engineers. So to put things back into perspective, maybe we can start with your understanding of the problem, and if you could share with us some data points regarding the main different type of materials used in the industry, the quantity they represent, and the perspective of like a respective contribution to greenhouse gas emissions.
So I think that the initial numbers are pretty simple. 39% of global emissions come from the construction and real estate environment. And in parallel, 38% of the global energy consumption. So this industry is pretty much the baddest boy in the neighborhood, no matter how you look at it. And if you look at materials and how we construct and the way we construct, you see that concrete, which is the first material we tackle, of course, is the most used one. By the way, concrete is second to water in human usage. So we use a lot of concrete. And concrete by itself is not that good. That means in terms of emissions, if you look at the life cycle analysis of 1 cubic meter of reinforced concrete, the global average will be around 500 kilos of CO2 emitted in its life cycle, which is crazy. And 1 cubic meter is nothing. You can imagine that 1 meter by 1 meter cube. That's very easy to understand. But now you look around you and you try to figure out, okay, how many cubic meters are around me? And we are surrounded by billions and billions of cubic meters of concrete. But not only that, if you go into the entire part of the building, you see that structure, the concrete structure of the building will take roughly 50% of the embodied carbon in the building, that means in the construction phase, which is crazy to be honest, just the structure, just the concrete. And the overall weight of the building will be 80% of the weight will be concrete. So it is a prominent player, but concrete is not by itself. You have steel as well, which is a horrible material, even worse. The good thing about steel is that we don't tend to use it so much and in those volumes as we use concrete. That means you can have the same structural properties with, of course, with less steel and less concrete and less, let's say, beams and columns. But at the same time, the price many times detects that you cannot use steel, but actually concrete, which is simple to use, cheaper usually. And that's another problem with concrete. It's still cheap. So it will be the automatic go-to for many construction companies. And moreover, when you will be over-designing with concrete, nobody, well, a certain number will care too much. Because if you look at the numbers, we know today from all the projects and the clients that we had is that over-design in terms of concrete can reach all the way up to 40, 50% even more. So you're building a building that has a 1.5 structures in it. And so that to understand the scope. And the thing is that nobody knew that we are getting to that point. Everybody knew that, okay, that's the way to do things, right? We need to add a little bit here and there. But a little bit here and there went to really big numbers. And the moment our clients or users realize that, that's creating a very big change. To understand that, oh my God, putting so much. And not only that, our client, the developer or the owner of the project is paying 10, 15% extra on the entire project, right? That's crazy. And when the developer and the engineers and everybody understand that, that's one of the changes that we're making in the industry as for now, and trying to eliminate as much as possible. Nonetheless, still there are gonna be some over design because just from security measures and so on, but at least they will know where is their zero over design. That's what we can provide them. And then to add 5, 10%, okay, we'll be okay with that, but not 40 or 50%, which is horrible in any aspect.
So speaking about like materials, you cover like concrete, you mentioned steel. Do you see any other like I would say material use in the construction industry that have a large footprint that you guys are not supporting right now, but to really get this full overview before going into more detail in terms of this allocation, I would say, and this overbuilding trends that you see. Any other data points or perspective that you could give?
So I can give a perspective outside the structure. That means when it comes to structures, you can build structures from concrete, from steel, wood. Now timber is getting very popular as well with very low carbon footprint. But at the same time, we don't really have enough timber for all the buildings that we need to build. So it's a good technology. It's a very sustainable one, without a doubt. Even a good material to live next to. Concrete is not that healthy, steel either, wood is, but we don't have enough of it. So that's one. But in terms of materials that I think over-designed, for example, glass, we don't tend to glass. Glass is not part of the structure, of course, but glass is very expensive on emissions because you actually need to, the temperature you need to achieve to cast the glass is pretty crazy, and you need windows. So either way. But again, in comparing to brick walls or stuff like that, glass will be worse. So it's always trying to understand the balance between how much light you want to take into the buildings, for example, and how much glass you want to use eventually, because using too much glass can actually provide more emissions, where the bricks that take the place of the glass will take usually less emissions for that weight.
Looking at those materials, and you're like working with them on a daily basis, like, do you see like emerging alternatives that are like greener, more sustainable, or like fully decarbonized that can support those three pillars? I mean, at least the two, cement and steel, and eventually glass. Or what is your take there? Do you see any emerging like technologies that are not just on the lab, or I would say on the headlines, but that real construction companies are starting to use and implement into their process?
One of the things that we hear a lot is about flying ash, which is a residue of, say, using coal, which is being implemented at the moment, replacing different elements within the concrete mixture and making that mixture with less emissions, and using a material that otherwise will be thrown away and contaminate the ground, now put into the concrete. And we can see the benefits because it's a good replacement, because it actually doesn't weaken the mixture as other materials do. But I know that there are extremely high-tech companies now that are doing, for example, using graphene in the mixtures in a very novel way, which is the thing is how you can combine the materials, which is the problem, because we have two strong materials, but how to combine them correctly. And that's one thing, a few things that we saw. And there are a few quiet companies doing that. But their challenge basically is not the scientific challenge. It's more about the regulation challenge, about how you can say, okay, this is a product that can go into the structure, into the concrete, and the regulators would be okay with, because eventually if that building will collapse because of that material, will be in a problem. So there's a lot of fear in there, I assume, but there's a lot of science as well. And eventually they're building more and more mock-ups and convincing more and more authorities about putting this into the regulation. So it's a process. And in the construction company, that process is take too much time, alas. But again, there's a lot of changes there. And as I mentioned, concrete is only one many that you can actually improve. You can improve the steel making steel. You can improve a lot of other materials. You can bring in different polymers, carbon, for example, which is the most popular material, by the way, but by means in the industry, in terms of industrial design, for example, they love that material. In cars, for example, you see that they're trying to implement that as well. But once again, it plays with the same problem as timber, that we don't really have enough in terms of volume. Still, we need more volume and regulations to actually put it into the mixture.
So before we look a little bit more deeper in terms of the regulation that is driving the change within the industry. Now that we understand a bit better, like the source of the allocation, the problems that can be represented by the over designing, some potential alternatives that you were mentioning. To get more complete and I would say understand the context, can you tell us a bit more about like just the basic of like who are the main actors in the construction industries today, and how is the market organized? I mean, what are their limitations or incentive to take initiatives to decarbonize the industry that you have seen?
So I think that if you look at it in the simplest way, the construction industry is an industry that overall, most of the stakeholders in this industry are playing on very low margins. That means they have very little place to risk. And when we talking about risk, it's change, of course. So They're very timid about changing the way they do things. It's not only about regulations, it's about the companies themselves. And that's one of the things that makes our industry kind of slow in adapting to new technologies. But at the same time, what we can see that the carbon aspect or the environmental aspect comes from an economical point of view. That means there is a carbon economy coming into our industry as well. It means many countries in Europe, North America, and Asia Pacific as well are doing great efforts to put in some new regulations and new benefits, actually hardcore benefits in terms of cash for those who can reduce emissions and can provide more sustainable buildings in different aspects. So, for example, one that pops into my head, pretty simple. It's in Singapore, the BCA, for example, where they have this parameter called CY. It's the Concrete Usage Index. That is a very simple index that explains how much concrete in volume you use per square meter of floor plan, because you can measure the size of your project by square meters of floor plan. And according to how much you use in volume, according to that, will provide you benefits and bonuses and all kind of credits that can later on be cashed in more building space or receiving less taxes and so on. So this is something that you see moving on into the industry, mainly because a lot of countries, different countries, see that with a very small change in the construction industry, you can actually achieve a very high impact on the environment. Again, because the numbers I told in the beginning, 39, 38, the colossal numbers. Just touch the industry a little bit and you get it, but you need to help that industry, at least at the beginning. And another thing that we see in many places, which is incredible, even without any type of laws or regulations and benefits, you have a lot of people, down-to-earth people who are buying houses, buying apartments, and they want to know exactly what happens. They want to buy a home that is as green as possible, because they feel they have their own responsibility about the environment and they understand that this is something that they can do. And you see more and more contractors and developers going into that path just under a better PR, let's say, having a better home or a more greener home for you to use. And that comes in very different colors, not only about the construction phase, but actually the type of insulation that you have, the type of materials used, how long will that home hold before you have to, just trash it and build new and so on. So there's a lot of parameters that can implemented. There's an energy score that you can have, like you have in your laundry machine. Well, same thing you have in a few countries when you're buying a new house. So all of that is contributing a lot. And I think that what makes our industry and what will take our industry and take it into the next level in terms of environmental responsibility and so on will come from the carbon economy. No doubt about it.
So to close this, this section, could you tell us maybe, you mentioned and touched on a little bit on this regulatory framework. Is that the main incentive coupled with, I would say, this PR, grassroots, demand of something greener and better to have those large organizations to start to request and implement at a larger scale greener solution? Or do you see that there is some framework that still need to be in place to really accelerate the decarbonization? Because you heard the IPCC report released yesterday. Time is not ticking, time is exploding, we need to do it right now. So what is the timeline that is realistic to make those massive change within the whole life cycle and the whole value chain of that? Do you see something blocking? What needs to happen to really accelerate that?
So I think that in terms of time taking, as you mentioned, it's exploding. We already had to be doing something more than we are doing right now. That's for sure, and that goes for any industry. That's the report showing that perfectly for anyone. But I think that one of the interesting frames that are being done today, that a lot of these construction companies, the big ones, I'll say, are relying on funds coming not from their own pocket. That means they will recruit a fund or take money from a fund to build some type of building that will yield a return for that fund as an investment. And you see that more and more of those funds, and banks, by the way, are moving into what we can call green funds, or the lighting here, green funds, or something that has to do with green accounts or green pension funds, for example. You as a customer that invests in that fund, right? You have some savings or anything of that kind in a fund. You want to know that that fund is green. That means that that fund won't invest in, I don't know, in petrol companies or anything of that kind. You want to know exactly who and what those companies are doing. And one of the things that a lot of those, say, construction companies or developers do is to provide a, let's say, ESG report and let's say more about sustainable reports showing how green they are to attract those funds. And those funds are getting bigger and bigger by the day because people actually are investing in those rather than in others, and pulling money from investments and from funds that are actually providing to gas and so on. So that's something as a frame, as an economical frame. I would say it has to come from the economical part, because otherwise it won't happen. So if it's from the client or from the funds that actually fund all of that activity or construction activity, and you can see it very clearly happening in the bigger construction companies, what we need to do is to find a way to pull that not only for the top tiers, but actually to all companies. That means if you want to build a building, you have to, even if there is no regulation, the bank that loans you the money or give you the money will require that. And it's starting to happen. And that is colossal. And that's, I think, will be the true solution for what's happening now, coming from the financial aspect, from the economical aspect.
Last
But
question
in a
on that
larger
sense.
scale, yeah.
Yeah, last question in that sense. It's like, do you see any difference between the EU slash, Israel, Middle East, US, and in Asia in terms of like this movement happening right now? Do you see any difference in between, or there's more like incentives or consciousness, I would say, or financial like pressure from stakeholders or like banks through their stakeholders?
I can talk from my own experience that what I found about, for example, areas like Hong Kong and Singapore is amazing. You see how the industry and the government is joining hands to provide all type of regulations that are sustainable regulations and threshold that you need to meet and so on. That is an amazing act. In Europe, you can see in different regions, in different countries, different acts and laws. In North America, you see it getting slowly. New York, for example, is leading in that aspect. New York is well on the top of the map in North America. But I'll say that from my experience, the most extreme thing that I saw was actually Hong Kong and Singapore. In Europe after that. So you see a lot of incentives scattered around, but they're very focused, and you can see that there are actually manuals that you can take now. And I'm not talking about only about LEED and BREEAM certificates that exist for a while already, and people are using them globally. But you see a lot of local regulations that are beneficial for those who actually use them and promote sustainability. And promote sustainability, you get financial benefits. And if there is something our industry likes, is financial benefits, no doubt about it. Again, tackling those little, that small, let's say, those small revenues that we do in our industry. So that's another way to make more revenue. Who will say no to that?
So Thanks so much for clarifying the whole ecosystem there and sharing your insights. So let's go deeper now into Structure Pal. I mean, you already uncovered a bit like the story behind it, but if you could reframe and how did you guys meet all together? I mean, what's the initial gap that you identified that led to the current version of Structure Pal? As I always ask, like, why did Structure Pal have to exist?
Well, so we're a group of structural engineers, by the way, which is the interesting part of the company, the people in the company. Uh, we design buildings in our life. We saw the over-design up front. That means we didn't came from outside the industry. We are from the industry, and we decided that we need to do something about it. And we can, because we're not only structural engineers, we are software developers as well, and we know how to implement AI as well. So we figured out, well, it's in front of our eyes. What can we do? Where can we start? And concrete was obviously the first one. Structures were the first one. Concrete structures were the first stage, because it's a very easy research that you can do, even on Google, and it'll tell you it's the worst. And we started trying to understand why it's happening. We understood why it's happening, and what can we do about it? That's the question. How to use technology to help, because you are in an industry that, as I mentioned before, nobody likes new stuff. Everybody if it's ain't broken, don't fix it. It's a very dominant phrase in our industry. And what we did is to say, you know what, we're not going to create a new software. We're not going to replace the software used by the engineers and the design managers and so on. We're going to integrate. We're going to take this AI and we'll provide only the benefits without anything else. I mean, only benefits. How we can create something that's only benefits? So the first thing was, well, we'll reduce their workload. Let's automate 50% of their work. Possible? Yeah, did it, checked. So this thing by itself is a major aspect, even before optimization, because when you reduce the design time, first of all, we don't have enough engineers as it is. This is one of the problems about our industry, that you don't have enough engineers. That's why we over-design a lot of our buildings, because you don't have time. You have a lot of projects to deliver. So you'll deliver something, a structure that works, that means goes through the codes and regulations, but far from being optimal, because you don't really have enough people and time to do that. So let's reduce the time. Let's help them catch up a little bit, some air, so they can breathe. That's the first thing. But the second thing is to let these guys say, don't draft, don't do the hustle of finding it through drafting the solution, rather specify it and let the AI give you the answer. So you will specify whatever you need to work with as the regulations, codes, loads of the building, the physics, pricing of the materials, emissions of materials, design limitations, and so on. Just pull that in and let our AI do the work. When I'm saying do the work is let the AI run in the background, let him design by itself different designs, learn from those designs, analyze those designs, and eventually provide you, after 1 hour or so, for your computer running by itself, by the way, you can go and have a coffee, and that's it. Have a fully drafted model, an optimal model with an analytical model, quantity reports, emission reports, calculation reports, everything you would do in 4 weeks in an unoptimized manner, you're going to have it now in 1 hour, fully optimized with all the numbers, without the ability to say, well, this is in work. It's working perfectly. We have all the data here to show you that it's working. Take that and let's go from here to more advanced stages of design, such as detail and execution. But you now have the best design, and it was done for you by the AI. You can look at it as let's say, a ChatGPT of structural design in some way, because it will run, it will iterate, it will find the best solution. It will look on a huge data set of options, and then it will tell you something that you, with your human cognitive capacity, will never achieve. That's one of the things that why we need AI, because we are limited. We're not stupid. We're limited. I mean, we're very creative. We're very good at providing the challenge, finding gaps, failing. But AI is good about taking all of that and saying, okay, according to that, let me give you the best thing that you can have. And that's what we constructed. It took us 2.5 years development to reach that artificial engineering, as we call it, which is crazy because even before commercialization, even before how much money we can do about it, it's from our side, it's taking humanity one step further in terms of technology, in terms of artificial intelligence. We're very proud that we did it. And happily enough, we had enough of investors that believed in the idea and believed in the team. We were able to execute such an impossible mission because neither the academy or other companies reached that point. We have competitors, we'll talk about them perhaps later, but we are in a point where it's incredibly surprising what it does and how it does, what it provides and how it helps, and how our clients react to that. That's what make me wake up every morning and hop on to my shirt and pants and go into the office with shoes, of course.
So I think, and I'm sorry to interrupt you, but I like to double click a little bit on the AI optimization. I mean, you already started to uncover a bit, but like, how does it work? How did you guys build this initial model? I mean, what are the source of data sets that you are using? How do you, in a way, double check, verify that what comes out of this optimization makes sense, and you don't find yourself with something that have been so optimized that will collapse after a few years in the making. I mean, what is exactly this AI, bringing into the game? You mentioned it that in a way humans are limited in some sort, and so explain us a little bit, because it's a very trendy wars nowadays with ChatGPT and GPT-4 released recently. Yeah. I mean, are we talking about a real game changer here, or is just a better way to put data into something?
So, long question will be a long answer. So in terms of AI, one of the problems we had in the beginning is the fact that we don't have any data. And the little data that we have is, well, it's rubbish. What do I mean by rubbish? Well, you already know that notion of garbage in, garbage out when it comes to AI. And that's the problem we had, because if we will take all the structures that were designed worldwide until today, we have millions of structures, right? And we'll create our data set from those structures and examples. Those will be the examples for the AI to run. Eventually, you'll ask the AI to provide a new structure. You'll get an unoptimized structure, such as all the structures that the AI has in the background in the data set. So that won't work. So we went into a different path of reinforcement learning. That means that we've created an agent that doesn't need that prior data, doesn't need that data set, but it will need all the limitation, the boundaries of frame he's looking for. That means those boundaries will be the type of material that he can use, the architectural design and limitation that it brings, the pricing, the loads, the regulations, the codes, everything that he has to meet. Those eventually can be framed into a landscape of possibilities. But that landscape of possibilities can reach all the way to millions of different designs. The question is, which one is the best in terms of optimization? I mean, which one is zero over design? And that was the biggest challenge, to build that agent. Now, what we did is an agent that will run in the background, but eventually will run between 1,600 iterations, not millions of iterations as you expect. And every iteration it will run, it will learn. What do I mean by learning? That means it will evaluate it in cost, it will evaluate it in emissions, and code and regulation requirement, that it meets all of those. And if it meets all of those, he will learn all the good steps he did, and next one, and next one, and next one, until he will be blocked and will say, okay, I reached zero over design. This is the best design you can have. Go on. Thank you very much. I finished my job. So every project you're going to pop in will have the ability to be truly optimized, because we don't rely on garbage data that we have in the near future, just imagine that will be running for so many clients, so many structures, that we can take that data that's been generated. That data will be the data set that we have. And then instead of 1 hour of running and 70 to 300 iterations, you're going to have it in one trained neural net that you're going to have a click and it'll just say, okay, this is the one, because I'm already trained. Getting that takes some time. Need some examples, of course, but we're running forward to get to that point. Just imagine you're going to have a building and in one click, you know exactly how much you're going to pay and how much emissions you're going to have from its structure. And that's a beautiful dream to have, just one click away. That's what we say.
So, but stepping back a little bit, as it's a long journey to reach that dream and that epiphany, or that North Star that you have. I still have listening to you, like 3 questions that pop up here. One is related to this regulatory framework. Is it applicable to everywhere, anywhere in the world, or is it right now on your case in the Israeli market, or maybe you're speaking about Asia? So what is the limitation there, and how challenging it is to implement those data to make sure that your model is running and optimizing the right way? Second question that I have is like, how do you verify, how long does it take you, or it took you to compare what the system has been like optimizing and giving you as an example compared to real life example, or like real structure that you have been building? So how does it work on that those 2 questions in a way?
Okay, so first, in terms of regulations, it's pretty easy, because one of the interesting part about regulations, it's something you can reparameterize. That means you can actually explain what it means. And in terms of codes, most of the codes worldwide are a derivative of a bigger code. I mean, the North American code, or the European, the British, and so on. So most of them are derivative with some local changes. And every time we enter a new region, for that matter, that has a different code in that region, it takes us a week or 2 just to implement those parameters, change and tweak it. So you can actually choose which code you want to comply with. Because something interesting, we discovered that in some countries, you'll have more than one code. For example, in Dubai, we learned that you have the American and the British code are building next to each other, just because something there happened in the past, and this will follow the British and this won't follow the American, some reason. So you can have all the codes. As an engineer, you can have all of them. Even if you're working in the US and you want to design a building in the UK, you can just choose and that's it. So every time a new geography comes in, we just implement that code. And again, because we're structural engineers, we know exactly how to reparameterize that code into numbers that the AI can understand. Now, the second one, which is a very interesting question about validation, how you know you're better than humans. That's the first thing. So what we did along the 2.5 years, even 3 years, is that we did a lot of pilots. First of all, pilots are good to benchmark to see if your system is actually working and pulling out something that's reasonable. But when you cross that reasonable and get into the competition with a human, that's the next step, how we can be better than a human. Our luck is that most of our investors worldwide are by themselves construction companies, or have LPs who are construction companies. So we had a reach for an incredible amount of finished projects. And the idea in those projects is that we will get in that project only the architectural part, without the structural part, without the structural design, and we'll go blind in. Same regulations, same code, same parameters as the human engineer had, but now let's see what you can do. And what happened is a classic benchmark. We can show our results, because in 1 hour you have the results and show them one in front of the other, and then you can understand, okay, this is 25% better than this, or 30% or 10% better than what I got. And the moment you see that, that's an easy sale, and it takes us very little time piloting such a thing. We're very used to piloting, so this is part of, even I'll say, our sailing mechanism.
Okay, but thanks for sharing that. So last question on my side on this topic. Say, Clearly, the concrete structure is something that now you guys sense that the model and the data set, not the data set, but at least the model and the operation is there. Are you planning to do that for other type of structures? We're mentioning like, maybe steels. There is also like, glass, wood, and timbers. Is that something that is achievable for you in the short term, the long term? Why are you in that process? And does it even make sense for you guys to go that way too?
A whole lot of sense, and it's on the pipeline, R&D pipeline in our case. I mean, it's already in motion. Not only that, we're very lucky of having different design partners worldwide, other consultancies who are more professional about designing with steel or with timber or with different concrete methods that were so happy to help us. And that's incredible to see these guys just pulling out of their time without having problems saying, you know what, we'll help you do that. So we have still a long way to go to the moment we'll be able to optimize every type of building with every type of material, but we're on that path. And we choose concrete obviously because it's the most used one, but still is in the pipeline, timber is in the pipeline, different type of construction methods with concrete and steel are in the pipeline, different type of buildings and so, et cetera, et cetera. So that is obviously in the way. And from our perspective, we won't stop until we reach all of them. I mean, concrete is only, as we mentioned, the beginning, the fat beginning. But another thing that it's important to mention is that another value that we can provide at that stage is that many developers, or also the clients that we have, will go into a project without really knowing which material will be best. So if for the moment they decided concrete, they will use us. But in the future, what we're going to provide is them telling them, look, if you want to go with steel, those will be the cost, those will be the emissions time schedules. If you do concrete, that will be. So they'll have a operative front of options with different materials and methods, and they can decide which one will be the best one. And that is a double optimization in terms of what we do, because we know today, and everybody keeps saying that, we hope that we chose the best method, but we don't know if it actually is. We don't have enough data to have that call, but we do it because we have to. So that's the second value, and let's say another 100% of value that we can provide there.
And are you thinking being able to reach like the same optimization numbers in terms of like the different material use, like again steel, glass, and or timbers, or the overbuilding is really more like specific at this stage for the concrete industry?
It's all of them. It's all of them. It will be all of them, and I can say it very confident because first of all, on an overall notion, the regulations themselves, the code itself is over-designed by fact. I mean, it's already over-designed. And not only that you take a lot of safety factors and a lot of unknown factors, not only safety, but things that you say, but I'm not quite sure how they're gonna do it on site. I'll add a little bit just to be secure, or because I don't know the contractor, for example, I don't know the project manager, I don't know how precise they are, so I'll add. Thing is that that's something that has to change. So in terms of over design, that's something that we can help. Understanding site, understanding design, understanding all the stakeholders, not just the designer. That's, of course, what will lead to the optimal position as optimization. Let's say gurus that were in that aspect.
So what are the current and expected economics of Structure Pal? I mean, what's your business model like? Do you have any future projection that you want to share, or can you tell us a bit more about that?
So we have what we call an unorthodox model. In most cases, you'll see that startup will try to push into a model that you'll have in terms of software, you have I'll say a one-time fee, for example, you purchase the software every year, for example, or a recurrent revenue, or that models. But we took a different path because we say we are a software. Yes, we are, but we're creating a new category within the workflow. And that category is financial and sustainable impact. And we need to be pricing according to that. So how do you price according to that? So the best thing is to fee ourselves according to square meters. I mean, the size of your project will tell how much you need to pay, because the moment you know how much we can save in percentage, and you know how much we're gonna ask for 1 square meter. And by the way, the entire industry works with a lot of suppliers paying them by square meter in any case. So it's something that the industry understands pretty well. They will understand, the client will understand on the same spot its ROI, whether it's 1 to 5, 1 to 10, 1 to 20 that we reached in our past as well. And that's why it will be an easy deal for him. But in terms of model, that's a model for penetration, of course, with first clients. But the idea here is selling banks of meters upfront. That means you as a client will buy 100,000, 200,000 square meters. You get a discount, of course, for that. And every time you build a new building, we will be pulling meters from that account according to the projects. And we always laugh that with our clients that the discount they're getting another building. That's a nice discount to have. To that. And in terms of projection, if you're taking the entire market and the amount that we're going to build, we are talking about $9 billion total available market in terms of revenues, just by asking $2 per square meter. That's a 9 billion one. Now, I mentioned before jumping into not only concrete optimization, but actually material optimization, at which type of material and what type of method you're going to use. That will cost an extra $2. So, and people are willing to pay an extra $2 for that, because that's double optimization. And we're talking about $4 per square meter. That's already a double, an 18 billion TAM, which is incredible. And the last thing, which is theoretical at the moment, to be honest, but will kick in 2025 from our side, we'll be going into infrastructure, bridges, roads, pipes, water channels, whatever you think about as infrastructure. And that takes all of that by 6 times big. Emissions and cost. And I think that the one thing that I like to say when you're talking about TAM or total available, it's not only about revenues, it's about emissions. How much can we reduce? If we reach that TAM, how much we can go? And we're talking about 144 trillion kilos CO2 emissions a year that we can take down. That's the most beautiful number I heard from my presentation ever. That's all I say. That's the best number I can provide in this presentation, because this number is incredible. Reaching that number will be incredible, but reaching half of it, even 10% of it, will be super for our world.
So, can you share with us a little bit about the competition, because you cover this large market, kind of like the steps to achieve to go up to there. But who else is playing there? I mean, like, how do you guys are now different, maybe better? How do you compare yourself from the available solution there?
So, in terms of competition, I'll say the first thing. A lot of people ask me, who's your competition? And I kind of, I don't have enough competition to share, but I do. But it was why so little competition? So probably not an interesting market. No. Don't be confused. The construction tech market has so many problems. The construction industry has so many problems that are untackled yet, with incredible times, that you don't have enough startups to tackle all the problems, let alone to compete on problems. So you will prefer going on a problem that nobody is tackling. Nonetheless, we do have 2 competitors that we know of, that are Tango Builder and the guys from Structure Plus, that we know of anyway. They run different fee models from what we do. They provide a solution that it's not integrated, rather it's a more cloud-based solution. It's kind of different. We tend to incorporate ourselves into the workflow of the structural engineer. They tend to be outside of it, so we see it as a benefit. So everything is streamlined in our case. Fee model, we tend to believe and know from the clients that we already have that our fee model is more acceptable. I don't know exactly how much they're earning, but I don't know if it's better or worse, but it's different. And I would say that depth of technology, the amount of R&D that was invested in the level of complexity and output that we can provide is overpassing our competitors at the moment. I would love them to step in and be more competitive. I would love that, because that's, of course, going to push us even faster to do things. But nonetheless, I think that they and us will be able to take into new directions. There's a lot of market to take. If we're talking about going into different materials or even going to infrastructure, they might go into other engineering parts like mechanical and plumbing and so on. So there's a lot of meat here still to take. So I'm not very concerned. They shouldn't be concerned either from us, because there's enough meat for everyone here. That's for sure.
So last question on the on that side. On my side, it's like, I mean, in your system, would you are you already today, or would you in the near future integrate those alternative building materials, like different type of concrete and stuff? Is your model being able to integrate those new things, or is it like still very focused on the existing type of concrete, for instance, that you have?
Even today, you can do it. Even today, I'll surprise you. But even today, because eventually concrete is a material that is being set according to 4 different parameters. As long as you know those 4 physical parameters of the concrete, we just give you a simple Excel sheet where you put all the materials, prices if you have them, the emissions from those materials, and so on, and that's it. It's in the system on a click of a button. So we did test it with our investors. For example, one of our investors / clients wanted to know what would happen if they change the mixture, and we'll have a very high impact, a high strength concrete with different polymers inside of it, and to understand what would happen with that. And they just gave us that material with those 4 parameters. We ran it into the system, and we could easily benchmark what would happen from that material in front of a common material like C30, C40, for example, strand. So that's something happening today, no problem at all. Love those, by the way.
So you can be definitely like a good promoters and enabler of those emerging companies to stick around with the big guys. So last question, myself, what's next for Structure Pal?
Wow. Next infrastructure Pal will be, the flat things. We're growing in people, in clients, in regions, in materials, in methods. We're just spreading all over the world. So if we're now only in Israel, in Hong Kong, and in Toronto, we're now venturing to Singapore as well, Australia. We see the US as well as the market, Britain, and so on. So we're spreading step by step. It's not that easy, but it's something that we're doing because all of the markets, and that's one of the good things about us, is that we can accommodate new markets pretty easy and pretty fast. So we can pilot pretty fast with new clients, get those clients, and luckily enough, we've been able to harness top tier clients from all these places that are basically beautiful, because if you have top tier clients, it means that if they're using your technology, that technology will go down to mid tier and low tier, of course. Eventually, you can't stay behind. So just going global, I think that's something. Concrete is a problem everywhere, and we want to be the one solving that. And again, not only concrete.
So last question, what's your personal opinion on the climate crisis? I mean, what would you say to the people who feel demoralized by all the already visible consequences on climate change today? Are we doomed?
No. We're in a very bad position, I'll be honest. And again, I'm not a scientist. I'm a person who can read a lot of reports and understand a lot of reports, and I know that we're in a very bad position. Are we doomed? I believe we still have the ability to do that. And I'm saying that because I'm in the most horrible industry and I'm doing something very powerful with our industry, and I'm not alone. And if you take this industry that's 38 and 39% of energy and emissions, and you hit it hard, you can. And I always say that if we reach our TAM, we can reduce 1% of global CO2 emissions, just Structure Pal. If we reach all our clients, we reach half, we'll do 0.5%. That's incredible for one company. So imagine what would happen if we'll have 10, 20, 30, 40 startups like us touching all horrible positions and points as we are touching. That's doable. If Structure Pal is a company that you can say about, well, that's doable, and we're here, obviously, and we'll have more entrepreneurs going into this direction, to this industry, that would be amazing. And I'm not discouraging all the entrepreneurs that go into wind power and solar power and water power. We need that as well, but we need a lot more of what we have at the moment in our industry, and that can make a huge change. So if you, and I'm looking at the camera now, if you're an entrepreneur, make that pivot, get into our industry. You won't regret it. One of the most interesting industries, no doubt about it. Come work with us, please.
So how can the community of experts, founders, investors listening to the show can help you guys?
Well, the first thing, and will sound weird, it's not money. First thing will be those connections, touching those top tier companies that are searching for something, and because it's a huge world and the internet is huge, didn't find us yet. That, I think, would be the best thing that we can ask for. Getting those points, getting into those, let's say, first doors, not 10 doors to get to the obvious man, but actually getting into the right person through the first door, helping with that, it's immense. And I can say that with full security because we actually had that experience so far. We're working with top tier construction companies because we had those investors, partners, accelerators even, that made that door open, and that really made a change. And I know for sure that it's impossible for a CEO or even for a chief innovation or chief sustainability officer in those companies to know all the landscape of options he or she got on her table, because there are so many. There are a lot of them in very early stage or early stage, but not doing very well and so on. So there's a lot of work there. So please, that's the first thing. And second of all, fund companies as ours, not only ours, fund companies of that kind. Even if you will read that the construction industry is a late adopter and a hard adopter and let's say a bad adopter, still take that leap of faith, because it's still 20% of the world money goes into that. Every 20% of every dime you're gonna have in your life will go into this industry. Simple to put it. So that's a huge industry, and if you make it, you make it big. You don't make it okay. No, you make it in super big, and that's a blue ocean, a very deep blue ocean, and they need to go into it fearlessly. Take the chance.
Any question that I did not ask you that I should have for this first part of the interview?
Wow, I talked a lot. I have to be honest. You asked beautiful questions and very on the spot. So to be honest, I don't know if I have any others. I would obviously, if someone sees this podcast and want to ask more, please let them have my email. I would love to answer any type of questions that coming from anyone regarding the industry and the company and myself.
Thank you so much, Ionathan, for your time, your incredible insight on the construction industry, all this hard work that you guys are doing with Structure Pal. Super excited to see you guys keep growing in the future and have this beautiful impact on the industry. And thank you so much for putting so much time and effort to move the ball towards a better and cleaner world. So thank you so much.
Thank you, Guillaume, for having me today. It's a pleasure, always a pleasure to talk in platforms like this one. It's, of course, and if this message will go, I'll say, further into the sea, why not?
Thanks again for joining us on the Tech for Climate podcast. I hope you enjoyed the show. Stay tuned next week for more climate tech insights. In the meantime, head on over to our webpage at startupbasecamp.org, where we have lots more insights and resources for anyone wanting to get involved in climate tech. If you find our resources useful, please consider donating to support our small self-funded team. Don't forget to subscribe and share with your friends. And see you next time.